Now, let us consider an example to illustrate the operations of quicksort. Let us arbitrarily consider an array of integers. Let the elements are 23, 10, 5, 16, 42, 19, 7, 62 and 71, and the indices are 0, 1, 2, 3, 4, 5, 6, 7, 8. Let us consider 9 elements, and our first task is to divide the array into 2 halves, such that the partitioning elements will occupy the correct positions and all less than this partitioning element will appear in the left of this partitioning element, and all elements which are greater than this partitioning element will appear to the right. That means, the partitioning element called the pivot element will occupy to the correct positions. So, for this procedure we are calling this as partition procedure, and this will return the index of the partitioning element, that is the positions, integer positions. So, we are calling this as partition and what is passed this array. Let us call the name of this array as A. So, array of integers int A, and this array is bounded by 2 indices low and high. So, at any particular unsorted array is bounded by low and high. So, we have passed these 2 things, int low and int high. Let us call this the start of this function. And initially, let us consider the first element as the pivot element. Okay. And to ensure that every element is examined or not, so we are considering 2 local variables, that is left and right, and the pivot element pivot. So, for this, and left is initialized with low and right is initialized with high, and pivot element is initially considered as the first element, that is A, name of this array, and low. So, this is my initial assumption, that is we are initially considering this element as the pivot element, and we have considered these 2 variables, that is 2 local variables, that is left, this is left and right, which are initialized with low and high. So, initially left is equal to 0 and right is equal to 8. Now, how we will examine? Our task is to ensure that all elements less than 23 will appear to the left of 23. So, the 23 will go to the correct position, that is our objective. So, for this purpose we have to ensure that every element has been examined. So, for this purpose we are setting a loop while, that is how can we examine that every element has been examined, that is left which will move towards right and right which will move towards left, and if these 2 crosses, that indicates all elements has been examined. So, that is why our terminating conditions is while left is less than right. So, as long as that we will continue. Now, what we are doing? We are first checking that the value at left positions is less equal to pivot or not. So, for this we are setting a loop, that is while A left, if this is less equal to pivot, then left plus plus. So, left will move towards right. Now, let us see what happens in this case. So, initially pivot is 23. So, A left, what is A left? 23, 23 is less equal to pivot, yes. So, left is moving to these positions. 10 is less equal to pivot, yes, left plus plus. So, left is coming here. Less equal to, yes, left plus plus. 16 is less equal to, yes, left plus plus. So, when the value of left is 4, that is holding this index, then what is A left? A left is 42, which is greater than 23. So, this condition is false. So, we are coming out of this loop. Now, the same thing is continued for right. So, we are setting another loop while A right, if this is greater or equal to pivot, then right minus minus. So, you are examining the elements from the right. So, what is A right? 71, that is greater or equal to 23, yes. So, right minus minus, right is coming here. This is greater or equal to, yes, right minus minus. Now, when right is equal to 6, this index, in that case A right, that is 7, this is greater or equal to 23, no, that is false. So, you are coming out of this loop. So, in this case, the value at right position should move towards left and the value at left position should go to the right of pivot. Now, how we will check that they should go in the correct positions? So, for this purpose we are checking if left, okay, if left is less than right, that means left does not process right, that means all elements are not yet examined. So, if left less than right, then we are interchanging, we are swapping in the array A between left and right positions. So, now what is done here? Here these two elements are now interchanged. So, after this interchange, the result will be like this. So, 23 is here, this is 10, this is 5, this is 16. So, these positions 7 will come, this is 19, this is 42, because 42 will move to these positions, and this is 62 and this is 71, and this is the positions of right and this is the position of left. This is low and this is high, and your pivot is same as 23, pivot is 23. Now, again all elements are not yet examined. So, this is the end of this while loop. So, again this while loop will start iteration, starts its iterations. So, again left is less than right, because left is now 4 and right is 6. So, 4 less than 6, that is true. So, again these two loop will be executed. Now, what is the value of A left? 7, 7 is less than 23, less than equal to 23, yes. So, left plus plus, this is less equal to 23, yes, left plus plus. So, now when left is here, that is 6, then the value at left, that is 42, is less equal to pivot, that is false. So, you are coming out of this while loop. Now, the same thing happens for the right. So, A right here, A right, that is 42, that is greater or equal to pivot, yes. So, right minus minus. So, right is coming here, this value 19 is greater or equal to 23, no, false, you are coming out of this while loop. So, now in this case the value of right is now 5 and left is 6. So, now left less than right? No, that is false. So, no need not required to be interchange. So, you are coming out of this while loop, because left less than right, that is false. What does it mean? Left less than right false means all elements are examined. It is very obvious here. This is the positions of left and this is the positions of right, and this left crosses right, that means all elements are examined. So, in this case, in this situation, this is the positions of right and this is the positions of left. In these positions, the value of right is the correct positions of pivot. So, you will interchange, you will bring the assumed pivot to the correct, to its correct position. So, now these two are interchange. So, after this interchange, what will be the result? After this interchange, you will get 19 will come to this position, this is 10, this is 5, this is 16, this is 7 and this will be 23 pivot element, this is 42, this is 62, this is 71. So, this interchange is done by another call of swap function in the array A between low, which was initially assumed positions of pivot, low and right. So, after this interchange, you just observe that the pivot element will go to the correct positions and all elements less than this pivot element is in the left side and all elements greater than 23 are in the right of pivot positions. So, these are all greater than pivot element. And this partitioning positions is actually the positions of the right. So, that is returned by these functions. So, return right. So, in this example, what is returned? Return with the positions of this right, that is 5. This is 0, 1, 2, 3, 4, 5, 6, 7, 8. So, this is the positions of the correct positions of the pivot. So, that is returned by this function.